Day 147, Schematics Homework. Number 1. In circuit F, which light bulb is on? So in this drawing here, we have one switch in the off position where there is an open gap between the knife and the terminal. So this is an open switch. And this switch here is shown in the closed position, in the on position, where the knife is touching both terminals. So there's an open gap here, and the current, the charges of the current cannot jump across that to reach this light bulb. So this bulb is definitely off. But current cannot flow this way either because it's a dead end. And so this light bulb is also off. This light bulb is on because charges can flow from the battery through the switch, over the bridge of the knife, so to speak, and to the next terminal down this wire to here. So this light bulb is on. Number 2. In circuit B above, you want to have the top bulb on and the other light off. Would you close the top or bottom switch? So if you want this light bulb on, you have to have this switch in the closed position so that there is no gap there. And so you're going to have this one closed, the top one. Number 3. Label circuit A above as being parallel or series. As I go from the battery all the way around, I don't see any branches whatsoever. So that's called a series circuit. Number 4. Label circuit B above as being parallel or series. As I start from the battery, going around, I see a branch right there. Branching circuits are parallel. Number 5. Label circuit C as being parallel or series. There's a branch going on, so it's parallel. Number 6. Label circuit D above as being parallel or series. As I go from the battery around, I don't see any branches, and so it's series. Letter E, or number 7. Label circuit F as being parallel or series. We have a branch right there, so it's parallel. Number 8. Label the switches in circuit A as being open, closed, or one of both. The switch here is shown so that the knife is touching both terminals. There is not any gaps there. Everything is closed up tight. Number 9. Label the switches as being open, closed, or both. We can see an open gap here between the knife and the terminal. So these are open switches. This is in the off position. No current is flowing through those switches. Number 10. Label the switches of circuit D above as being open, closed, or both. The knife is touching both terminals. The gaps there are all closed up. So it's a closed switch. That means that current is flowing. That is in the on position. Number 11. Label as being open, closed, or both. We can see that there is an open gap there between the gray knife and the white terminal. So that's an open circuit. It is in the off position. No current is flowing. Number 12. Are the batteries considered to be in series or parallel? So we're only looking at this section right here with the batteries. We're not looking at the entire circuit. The entire circuit would be called a parallel circuit because there's branches there. But in this one part with the batteries, there is no branch. Any charge that gets pushed out by one battery has to go through the other battery. And so that would be a series section of this circuit. Number 13. We're matching the schematics with the quote-unquote pictures or diagrams or photographs, whatever you want to call it, down here. So number 1, we have 2 batteries in a row. So that's not going to be this one. Here we have 2 batteries in a row. not going to be that one. It could be this one. It's not that one, and it's not that one. So it's these two. Okay, so we have the battery, and it comes up. It got cut off here a little bit. But anyway, then there's a branch, and each branch has two items. One is two light bulbs, and one is a light bulb and a switch. So, looking here, we have the two batteries, and we have two branches. But this branch here only has a switch. So that's not it. This entire circuit has 1, 2, 3 bulbs. And this has 3 bulbs. But here, every charge that leaves the battery has to go through these 2 bulbs. That's not the case here. They go through the battery, and some of them go through these 2 bulbs, and the rest of them go down this way. So this is not that one. It must be this one here. Let's double check. We have current flowing out of the batteries, and it either goes up through 2 bulbs or down through a bulb and a switch. Over here, they go through this, charges go out the battery, either go up to 2 bulbs or down to a bulb and a switch. So this is that one right there. Oh, this one here. So let's draw an arrow. Okay, number 2. We have 3 branches and 1 battery and 1 light bulb on each branch. Here's 1 battery, but we don't have the branches. Here are branches, but we have too many batteries. Not enough branches, not enough batteries. Not enough batteries, not enough branches. Must be this one. 1 battery, 1 battery. 1, 2, 3 bulbs, 1, 2, 3 bulbs. 3 branches, 1, 2, 3. 3 branches, 1, 2, 3. Yep, this goes there. Okay, here, this one got cut off a little bit. I'll draw in what's missing. We should have another battery here. On your screen, it should be there. It's just that with my printout, it didn't show up. So we have 3 batteries, 1 on each branch. We have 3 bulbs all in a row on 1 branch along with a switch. That's this one right down here. Here we have a series circuit. There are no branches. Every charge that comes out of the battery has to go through this bulb, and that switch. These have branches, so they are not the answer. There's only 1 series down here. There you go. Charges go out the battery, through the switch, through 2 bulbs. Here's the battery, there's a switch, there's 2 bulbs. The location of these items is not exactly the same from the schematic to the diagram, but the order is the same, and that's close enough. Okay, 2 more. This one has 2 batteries. This one only has 1 battery, so we can easily say that's going to be there, and this one is going to be there. Did I do that right? Egads, no, I did not do that right. 2 batteries, 2 batteries. This one goes here. Drat. Scribble, 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 scribble. This one has 1 battery. It goes all the way over to here. Oh, rats. Okay, let's move on quick before I make another mistake. Number 14. What's the most common metal used in wires? That's going to be aluminum and copper. Number 15. Do these common metal wires from previous questions have any resistance? In other words, the copper and silver, copper and aluminum, do they have any resistance? And the answer is yes. It's just that they have the least amount of resistance for common metals, for common ones. And so it's cheap enough, and it's low enough resistance, good enough, let's make our wires out of it. How do household light switch dimmers work? That's with variable resistors. And let's draw a little diagram of that. So here you have a wire, and then here's your dimmer switch with, let's say, a slider back and forth, and then there's a wire going out of it. Inside, the wire is attached to another material, like that has a high resistance. And then this wire is connected to the slider. And the slider is either connected to here, or this connection point can move back and forth. And so as current comes in, it either flows through a lot of this resistor to the next wire, or if this is slid over, way over to here, it only goes through a little bit of the resistor, and then it goes to the wire. So depending upon how much resistance, the light gets brighter or dimmer. Number 17, describe the motion of electrons in a circuit wire that's conducting electrical current. It does not go just in a straight line. It bounces around, up and down. It generally goes down the wire, but it is not a straight line. It's going to be a zigzag line. An open circuit versus a closed circuit. Open has an open gap somewhere with air between two wire ends. Closed circuit, all those spaces are closed up. Things are all touching, so charges can flow from one part to the next. Number 19, contrast parallel versus series. A parallel circuit has branching wires. Series does not. Your skin's resistance to current is used in lie detectors. The theory is that the more stress you are under when lying, the more your skin will sweat. The salt water of sweat has lower resistance than dry skin. So the conductivity of your skin is only part of the lie detector. There's also things like heart rate and breathing and other such things. Number 21, these lie detectors are not reliable. Number 22, when the crest of a sound wave hits a diaphragm, carbon granules are squeezed. And so therefore they have more points of contact, and there's less resistance in the microphone, and more current comes out of it, and the stereo or amplifier or whatever uses that varying current to transmit your sounds. This squeezing causes the resistance of the granule to decrease because there are now more areas of contact. Varying amounts of resistance will cause the current in the microphone to vary in that type of code that corresponds to different sounds. Number 23, or 25, what is the name of the unit for current? That's the ampere, often known as just simply amps. What's the name for the unit of energy of the charges? That's the voltage, or simply volts. And that should be the end.